What do we got today?
I don't really have any, like, I don't have a worksheet or anything, so I don't know what you want me to do.
Do you have a book?
No.
Do you have a website? In other words, I need you to bring problems to the table. I can't bring them to the table because I really don't know the exact area you're working in.
Yeah, I think I have some. Hold up.
Okay, that's all I need is you to bring problems to every session. Because I'd be shooting in the dark if I
Mm-hmm.
started making up problems. Every subject is too broad. I have no idea where you're at in a particular subject or what the degree of difficulty that your teacher is giving you.
All right, I have one here.
Okay. And if it can be verbalized, fine, go ahead and verbalize it. If it can't, then you need to take a picture and send it to me.
All right, give me a sec.
And when you send pictures, don't send them to my phone, send them to my email address.
All right, here's one.
Okay.
21x squared minus 58x plus 21.
I want you to factor that.
Mm-hmm.
All right. First thing we need to do is figure out whether we can simplify it. Is there a greatest common factor? That's the first question.
Yes.
What would
I
that be?
think 7?
7 does not go into
Or no.
8.
Yeah, no. There's not then.
Correct, there isn't. One of the good rules to know. First of all, 21, the only thing that goes into 21 is 7 and 3.
Mm-hmm.
Okay? So 7 doesn't go into 58, but does 3. And there's a real easy way to figure out whether a number is divisible by 3. That is, add up the digits, 5 and 8, which is 13. Keep adding. If that number is divisible by 3, then the original number was divisible by 3. And 4 is not divisible by 3, nor is 13. So we know it's not divisible by 3. It's not divisible by 7. So there is no greatest common factor. So now we're going to do it the hard way. But it shouldn't be that hard because there aren't that many factors of 21. In other words, we got two jobs. We got to split up the first x squared, and we have to split up the number. And they have to be split up in a way that gives you minus 58 as the middle term. So what's the best way to start this problem?
Use 7 and 3 because they're the closest together.
Not 7 and 3, but it's 7x and 3x. Notice that the very first thing I do is multiply them back together again, gives you that term. That is the only thing that affects that term is those first two terms, nothing else. Okay? Now, it doesn't necessarily have to be 7 and 3. It could be 21 and 1. But this is a trial and error process. So this is as good a place to start as any. What's the second step?
It would be a plus and a minus sign. Yeah.
Create a plus 21 with a plus and a minus.
It would be both minuses and then.
Okay. That's huge. That is always the second step. That is the hardest step that I get have my students try to remember. None of them want to do it. I don't know why. To me, it makes the problem much, much easier. Okay? Now, I am looking for factors of 21. In other words, whatever I write there and there have to multiply to 21. Because just like that first term, this last term is only determined by the two numbers. Okay? So we're again at 7 and 3, or 21 and 1. What should we start with?
You would start with 7 and 3.
All right. I have no idea. I'm not thinking ahead. Just starting there. Now the trick is to see what kind of first or middle term that produces. And this becomes part of the solution, not just a checking process. This is absolutely part of the solution. What middle term does that produce?
That produces a negative 21 and so a negative 42.
It's not the right term. So it ain't that. So the next thing we should try is what?
You should try switching the signs.
3 and 7. What does that produce?
That produces negative 9x and negative 49x, and yeah, that would be right.
Bingo. And that's the nature of these problems. You just keep trying possibilities, starting with the two factors that are closest together, not just with the x squared term, but also the number. And that's usually the answer. It's pretty rare in Colorado when they give you a hard factoring problem for it to be, they just don't give you problems where the two factors are the two furthest apart. They just don't. 10% of the time. Okay? So since it's a trial and error process, you always start with the two numbers closest together. What else you got? Now notice one thing. When you get to these second degree quadratics, by second degree I mean coefficient of that first term is greater than 1. Okay? When you get to them, part of the solution is that double smiley face that I draw. The O and the I of FOIL. That's not just a checking process. That's part of the solution. Whereas when you have first level quadratics, you don't need, that's just to check to make sure you did it right. It's not part of the solution. Okay, so remember that. Okay, so what else you got?
All right, 5y squared plus 37y plus 14.
Okay, not too bad. And the reason I say not too bad is because there's only one set of factors for 5y squared. What are they?
5 and 1.
Give me the whole thing.
What do you mean?
Well, what do I have to write there and what do I have to write there?
It would be y.
Not 5 and 1. Because that would multiply to 5. I need it to multiply to 5y squared.
So it would be 5y and then y.
Good. Second step.
Both addition signs.
Now, all those rules, like factors of 14 that add to 37 or factors of 14 that subtract to 37, you cannot use those on these kind of quadratics. And the reason you can't is because this coefficient is 5, this coefficient is 1. So none of those rules apply. You're down to trial and error. Factor 14 and 1 for me.
So 14 and 1 and then 7 and 2.
That's it. Which one are we going to try?
7 and 2.
Arbitrarily. In other words, I don't know if it's 7 and 2 or 2 and 7. I'm going to try 7 and 2. Does that work?
7, 1, no.
Not even close. So I'm immediately going to switch them and try 2 and 7. Does that work?
2, yes, it does.
Yeah, bingo. We got our answer. So even these harder problems are not really that hard. You just have to follow the correct method every time. And I don't know, did they teach you something in school called the California method or the diamond method?
Nope.
Good, because both of those suck. Okay? As far as I'm concerned, the way I factor is the best way to factor. Even though they don't really teach this method in school, they should. It's really not that hard. You just have to remember what factoring is. It's the reverse of foiling. And when you foil something, that term right there is the only term that's based on two different multiplications. This term is based only on the two left terms. That's the F of FOIL. This is the L of FOIL. The O and the I create that term right there.
Mm-hmm.
What else?
All right, I got some more. All right.
Blake, you still there?
Yeah, all right, here's one. So 256s squared minus 196.
What's different about this?
There's not another S.
There's no S term, right?
Mm-hmm.
That's actually big. That's really, really important. That means we do not solve it the way we typically solve quadratics. If we have a normal quadratic that has an S squared and an S term and a number, then we're going to factor it, just like we've been doing today. But when you have this, where you have just the squared term and just a number, it's a completely different story.
Mm-hmm.
Now, when you go to factor stuff, you start there, right?
Mm-hmm.
What's that stand for?
Greatest common factor.
Okay. So we could start there. But before we do, and I know there is a greatest common factor because I'm looking at an even number and an even number. So I know I can divide at least both sides by 2. At least. Maybe more. This might be divisible by 4. And this might be divisible by 4. Incidentally, to determine whether a number is divisible by 4 or not, you look at the last 2 digits. If the last 2 digits are divisible by 4, then the whole number is divisible by 4. In other words, if I give you this number right here, that's divisible by 4. Why? Because 56 is divisible by 4.
Mm-hmm.
96 is also divisible by 4. So I know I can at least divide both sides by 4. But before I do that, what's the second thing you look for? And it's in things like that, where you have just a squared term and just a number, and they are being subtracted. I call it dopes. What does dopes stand for?
I don't know.
Difference of
perfect squares.
That's what it stands for. Now, you can only, well, it's not really true, you can only, but at your level of math, or at high school level of math, you're only going to apply dopes when you're dealing with 2 perfect squares. So the question is that a perfect square?
Yeah.
16s squared is 256s squared.
Mm-hmm.
Okay, so here is the standard formula for difference of perfect squares. I'm going to write it down here. A squared minus b squared is always equal to a minus b times a plus b. So if I give you an easy one, like x squared minus 25, how does that factor?
It would be x, and then it would be
When you're doing, let me stop you just for a second. When you're doing difference of perfect squares, you don't do it the same way as you do factoring. You don't do x. You figure out the first term completely, all by itself.
x minus 5x plus 5.
Exactly. In other words, once I've figured out that it's x minus 5, I'm done because I know the second term is x plus 5, always. So it's a little different mental process when you're doing difference of perfect squares. Okay? Now, the question in this problem, before I go factoring out a 4, is 256 a perfect square number?
Yes.
Yeah, it's 16 squared. So if that's a squared, then a is 16s. Is 196 a perfect square number?
Yes.
14. In other words, if I can take the square root of that and come up with a whole number, and if I can take the square root of that and come up with a whole number, then that's the first part. That's this x minus 5 or a minus b. What's the second term?
It's, what do you mean?
Well, we've got the a minus b part. What's the rest of it? Here's the formula over here. This is the formula that controls everything.
Oh, a plus b.
Okay, what is a plus?
So 16s plus 14.
Perfect. In other words, only thing I have to do is figure out that term right there. Once I figured out that term, the rest of it's automatic. I don't do it the same way at all. But that's fully factored. It's not quite fully factored. They want you to fully factor something. They really don't want you to stop until you're completely done. Is there anything I can factor out of everything that I'm looking at?
A 4?
Well, I can certainly take a 2 out of that one. So let's do that. The best figuring out that it's a 4 is not as easy as it sounds, but I can take a 2 out, leaving this, right? Now I can take another 2 out of the term on the right, so that makes that 4. And it turns this into 8s minus 7. And that's actually the final answer. I cannot factor that down any further. In other words, I can't do anything with 8s minus 7. Excuse me, this is a plus over here. It doesn't change the sign factoring a 2 out. What it does do is makes the total amount that you factored out a 4. Now notice why it's tough to factor out a 4 all at once there. Because 4 does not go into 14. I could take a 4 out up here and actually would have worked pretty good. What I would have ended up with would be 4 times 64s squared minus, what would this have to be? 49 times whatever. I would have still, let's see, if I divide that by 4, what do I get? 59. No, it's not 50. Yeah, it is. No, it isn't 59. It's 49. In other words, I could have done it this way up here, like that, where I factor out the 4 first, and notice that I'm still left with difference of perfect squares. Factor that, what I've just underlined there.
That would be a...
I want you to factor it from the get-go. In other words, pretend that you never saw this problem before, and you're factoring 64s squared minus 49. Is that difference of perfect squares?
Yes.
Okay, what's the first term?
The first term would be, it would be
The first
S.
term is always, just so you know, it's the square root of that. What's the square root of that?
8.
8s.
8s.
What's
So
the
it'd be
square root of that?
7. So it'd be 8s minus 7, 8s plus
Always.
7.
That's the first term, and it's always got a negative sign. Second term's easy once you get the first term. So actually, if I would have factored out a 4 before I did anything else, that's actually the easiest way to do it. So it really was greatest common factor first, and that factor was a 4, and then dopes second, where you look for difference of perfect squares. And you only go to factoring in the third case.
Mm-hmm.
In other words, if you can't do a greatest common factor and it's not dopes, then you do factoring.
Mm-hmm.
What else you got? We've got time for one more. And these are good to do. It'd be hard for me to come up with one because these are harder. I don't know what 2 factors multiply to 57s squared and stuff like that, you know.
Mm-hmm. Let's see.
Or give me a different type problem. I mean, we've done,
A different what?
we've done the whole session on factoring higher level quadratics and difference of perfect squares. Do you have anything else?
No, not really.
Let me give you one. Factor that.
Okay, so X is on both sides. And then it would be a, both would be, or one would be a addition, one would be a subtraction sign.
Plus minus. That's the way you say that.
Okay, and then, so it'd be,
Go ahead, verbalize it. I want you to verbalize it.
okay, so factors of
5 that do what?
that add or subtract to negative, or to
Not
2.
add or subtract. It's not add or subtract. It's definitely this one right there.
Subtract to
Always.
2.
Always. It's, in other words, if that's a negative sign, then they have to subtract. If that's a positive sign, they have to add.
Mm-hmm.
Okay? Well, here's my factors of 5. Do they subtract to 2?
No.
So now what do I do? In other words, I've just discovered that it doesn't factor. It doesn't factor into nice whole numbers. So when that happens, what do you do next? It's called the quadratic formula. Have you had it?
No.
Well, I'm going to give it to you because they're about to give it to you. And since we only have 5 minutes left and you can't come up with any new problems, let's do this.
Okay.
That's it. Now, you know how they taught you a song when you learned your ABCs?
Mm-hmm.
Well, there's a song for this. And the only thing I don't know what the song is. I mean, to this day, the only reason I know my ABCs is because I can sing the song. But the quadratic formula, you have to memorize this.
Mm-hmm.
You're not getting through high school without memorizing this. They make you memorize it for the SAT. They make you memorize it for the ACT, all your college entrance exams. And they make you memorize it for all your math classes. And they do not give it to you.
Mm-hmm.
So whatever you have to do to memorize that, memorize it.
Okay.
Now, question is what do these letters mean? What's A in this problem? And this is what I have to do to solve it if I can't factor it. This is the last alternative. This will give me a solution.
Okay.
What is A?
A in this problem would be X, or wait.
Coefficient of those things. What's the coefficient of x squared?
X? Wait, what?
What number is not written but assumed? 1.
1.
If you see a variable that does not have a coefficient in front of it, it's always 1. Don't forget that. That's extremely important. Okay, what's B?
B would be the 2?
It includes the sign.
-2.
What is C?
Is -5.
Okay. So, if I wanted to factor this quadratic, let's say I had it equal to 0, and I want to know what they are, then it's minus b, which is plus 2. You see that?
Mm-hmm.
Plus or minus the square root, b squared, that's 4, minus 4 times 1, which is a, times c, which is minus 5. All divided by 2a, which is 2. Now what that gives us as a solution, I'm going to go ahead and erase this for the moment, just because I need space to write, but you will learn this shortly. So what my solution is x equals 2 plus or minus the square root, well that becomes 24, everything inside the radical, all over 2. Well, now that reduces to 2 plus or minus 2 root 6 all over 2. Can divide top and bottom by 2. So that reduces to this. That's my answer. There's 2 answers. 1 plus root 6 and 1 minus root 6. Both of those solutions are a solution to that quadratic. And that is the fourth method that you use. When you can't do any of the first 3 things, the fourth method is this quadratic formula. And that always gives you the solution. Now notice the solution is not a whole number. It's 1 plus root 6 is one of those irrational numbers. It's about 2.5. Not exactly, but it's close to 2.5. So that's 2 solutions. When you see a plus or a minus and everything's numbers, and one solution is 1 plus root 6, the other solution is 1 minus root 6. If I plug in either of those solutions into that equation, it will be an equation. It will have the left side equal to 0. Okay?
Mm-hmm.
All right. I'm going to let you go. Sorry for taking a little bit longer. I actually have a 5 o'clock that I got to get to. So, Blake, I'll talk to you later.
All right, thank you.